Hello everyone, my name is James Ryan, and welcome to Teaching Tuesdays. Today I'm here to tell you about photosynthesis, but first, an introduction. So, you helped James solve a crime on Wednesday, on Whodunit Wednesday, and you've gone through your work on Thursday. When you get home, you feel like doing more. You feel like teaching. You feel like learning. Or perhaps you don't feel like learning. You feel like doing anything but. You feel like just resting at home. But either way, James knows what's best. And he knows that a good, healthy dose of learning is exactly what you need and what will cheer you up. Especially when learning is done on your own. Done by your own word. And not because you want to learn and not because someone else told you to, such as, for instance, your boss or teacher told you needed to learn something. So, for that, James presents his remedy, Teaching Tuesdays. Today on Teaching Tuesdays, we'll be learning about photosynthesis. So, what is photosynthesis? Well, photosynthesis is when plants combine the water from the ground. You know what? We need a song. So, what is photosynthesis? Well, photosynthesis is when plants take the water from the ground and combine it with carbon dioxide molecules in the air, and then combine them using the energy of the sun. But how exactly do they do this? And what does it produce? Well, let's find out. We'll need to take a look at some chemical formulas. We know that the chemical formula for water is H2O. And the chemical formula for dioxide is CO2. So, what are the products of this chemical reaction? Well, they are glucose, that's that thing, and some oxygen. Secret, yeah. Let's tidy this up, shall we? More secrets. There we go, that's a lot cleaner, don't you agree? Now, in case you didn't already know what all of these letters mean, H2O means that it consists of one oxygen atom surrounded by two hydrogens. That's a water molecule, while CO2 means that it's one carbon atom surrounded by two oxygens. Yeah. And C6H12O6 is the chemical formula for a different atom molecule called glucose, and O2 is pretty much similar. You can probably guess what that is. It's two oxygens bound together, just like this. But as you can see, this doesn't match up. It's not the numbers. The numbers just don't work. The numbers are wrong. You got two hydrogens over here, but 12 hydrogens over there, 3 oxygens over here, 8 over there, 1 carbon here, 6 over there. Something's gotta give. What we gotta do is called balancing equations. So let's see, we've got 2 hydrogens over here, but we need 12 in the final product. So what we gonna do? We can increase the amount of each molecule in this reaction, but we can't change the amount of each atom in each molecule, because that would be changing the molecule, and would be a different reaction. So, what times 2 equals 12? Well, that's 6. So the number we gotta put in front of this H2O is in fact 6. Now we gotta get 6 C's, 6 carbons over here. And to do that, we need to increase this C over here to 6 as well. So now we've got 6 water molecules and 6 molecules of carbon dioxide. And we've got to match up now with the oxygens on the other side. We've got 3 oxygens over here, and we've got 8 oxygens over there. If we change the glucose molecule, we'd be messing with that. But if we change the O2, we can fix everything. So what we gotta do is get this O2 and figure out a number that will make this all become 12. Well, 2 times what plus 6 equals 12? Actually, why am I saying 12? How many are there over here anyway? There's 1, there's 2, 3, but they're both times 6, so that's 6, 12, 18. We need to get 18 over here. So 2 times what plus 6 equals 18? Well, let's figure it out. It's actually 6. Again, because 6 times 2 is 12, plus 6 is 18. So now we just check if everything's balanced on both sides of the equation. We've got 12 hydrogens over here. We've got 12 hydrogens over there. We got 6 carbons over here and 6 over there. And what about the oxygens? Well, we've got 6 oxygens in this molecule, and we've got 6 O2s on this molecule, which becomes 12. So 12 plus 6 is 18. What about over here? We've got 6 oxygens all in this glucose molecule. We've got 12 included with these oxygen molecules. 6 plus 12 is again 18, so everything's balanced. Whoa! So what do we do now? We've done it. Oh, we've done it. I've shown you what we're doing. But, just to hit the point home, I'm gonna show you how this is done. First of all, we need to draw 6 H2Os. I said 6 H2Os. Now we need 6 CO2s. 1, 2, 3, 4, 5, 6 CO2s. Now we gotta somehow make this all into one glucose molecule and 6 O2s. But we don't even know what a glucose molecule looks like. Or do we do? Turns out it looks like this. Woo! Now let's see if we can turn this into this. We'll have to match all the atoms up with this. The carbons all go into one of these spaces, 'cause that's how organic chemistry works. Organic chemistry mostly involves molecules that involve carbon, because carbon is found in most molecules in life. So we put the carbons over there and the hydrogens over here. In fact, almost every one of these has a hydrogen attached to it. So a hydrogen attaches here, and a hydrogen attaches there, and a hydrogen over here, another hydrogen over there. And there's no more hydrogen groups, but what do we have instead? We have hydrogen-oxygen groups over there. The carbon connects to the oxygen, which is then connected to the hydrogen, and around the same thing happens over here. Don't worry, it may look like I've got the hydrogen in the wrong place, but it's okay, 'cause it still matches up just the same.